Hey, what's up everybody? In this video, we're going to talk about the dilution of solutions. So to dilute a solution basically means just to water it down, to keep adding more and more solvent to that solution, and that results in a solution that has a much larger volume and a much lower concentration. So what we're looking at here in this image is a bottle of concentrated hydrochloric acid, and this is what chemists like to refer to as a stock solution. So oftentimes solutions are kept in these very concentrated forms called stock solutions, and that saves a lot of space because when you need a solution of a lighter concentration, all you have to do is just add solvent to a certain volume of your stock solution, and that will give you your dilute solution of the concentration that you desire. So suppose you are doing just that. Suppose you are diluting a solution, so you take a certain volume of a concentrated solution and you add some solvent to it, and of course that results in a solution with a much larger volume and a much smaller concentration. So let's say you dilute that solution to a larger volume. Well, wouldn't it be great if you could figure out how concentrated that resulting solution is? Is there any kind of formula that's going to help us solve for that? Well, luckily there is, and it's called the dilution equation. And it basically looks like this. It says that M1V1 equals M2V2, where the M1 and V1 are the molarity and the volume of the solution in the concentrated form, and then M2 and V2 are the molarity and volume of the dilute solution. So M1, V1, that would be like the molarity and the volume of a very concentrated stock solution, and then M2 and V2, those are going to be the molarity and the volume of that watered down dilute version of the solution. So this problem says, to what volume should you dilute 0.5 liters of a 12.0 molar HCl solution to obtain a 3.0 molar HCl solution? So again, in this case, we're going to use that M1V1 equals M2V2. So at this point, we have to identify what we have and what we're trying to find. So it looks to me like the 0.5 liters and the 12.0 molar, that is the volume and the molarity of the concentrated solution, and then the 3.0 molar, that is the concentration or the molarity of the dilute solution. So in other words, and what I've done is I have labeled what we have, the stuff that is known, with red asterisks. We know M1, V1, and M2. We don't know V2, so we need to algebraically solve for V2 and then simply plug those numbers in, and that'll give us the value that we want. So again, we're trying to solve for V2, so this is as easy as just dividing both sides of this formula here by M2, and this equation is going to become V2 equals M1 V1 divided by M2. So at this point we have solved for V2. All we need to do is just plug those numbers in, so it's going to be that 0.5 liters times 12.0 moles per liter. Remember, molarity just means moles per liter. And then that whole product is going to be divided by 3.0 moles per liter. And once you crunch this into your calculator, the answer that you're going to get for that second volume, V2, is going to be 2.0 liters. And this makes sense because the volume is going to be much larger for a dilute solution than it is for the concentrated solution. For the concentrated solution, we were only dealing with half a liter, and now we have a dilute solution that has a volume of 2 whole liters. So intuitively, this makes a lot of sense. So I hope this video helped you out a little bit. In the next video, we're going to talk about something called solution stoichiometry. So if you're interested or you need any help with that kind of topic, please, by all means, stick around. Thank you for watching and have a great day.